MS Ramaya University of Applied Sciences.
Hi students, let us discuss time division multiplexing. The aim of the experiment is study of time division multiplexing. Time division multiplexing (TDM) is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line so that each signal appears on the line only a fraction of time in an alternating pattern. Time division multiplexing (TDM) is a method of transmitting and receiving independent signals over a common signal path by means of synchronized switches at each end of the transmission line so that each signal appears on the line only a fraction of time in an alternating pattern. It is used when the bit rate of the transmission medium exceeds that of the signal to be transmitted. This form of signal multiplexing was developed in telecommunications for telegraphy systems in the late 19th century but found its most common application in digital telephony in the second half of the 20th century. The apparatus required are Syntec 2153 kit with power cords, digital oscilloscope, probes and connecting cords. The connection diagram is as shown. Procedure is mode switch in 320 kHz or fast mode position, DC signal 1 and DC signal 2 controls in function generator block fully clockwise, 2 kHz and 4 kHz control levels set to give 10 volt peak to peak, pseudo random sync code generator on or off switch in off position, error check code generator switch A and B in A is equal to 0 and B is equal to 0 position or off mode. All switched faults off. First connect only the 2 kHz output to channel 1. Turn on the power. Check that the PAM output of 2 kHz sine wave is available at sample and hold input of the Syntec 2153. Connect channel 1 Y of the oscilloscope to channel 1 sampling signal. Output of demultiplexer block of channel 2X of the oscilloscope to input of sample and hold block. Observe the timing and phase relation between the channel 1 sampling signal and the sampled waveform at input of sample and hold block. Figure 5.1 shows channel 1 sampling signal and sample and hold output in dual mode. Figure 5.2 shows channel 2 sampling signal and sample and hold output in dual mode. Time division multiplexing. Figure 5.3 shows channel 1 input and sample and hold output when only one input signal is present. Figure 5.4 shows channel 2 input and sample and hold output when only one input signal is present.
Hi students, current experiment is time division multiplexing. Here in this experiment we demonstrate how a single channel can be used by the two users by choosing the different time slots for the each user. For this experiment I am using the Syntec 2153 board. This is the time division multiplexing setup. Here we are using the channel 1 and the channel 2. For each channel they have the multiplexing channel 1 and the channel 2 for the same channel. Means for the time slot 1 this switch will be closed, for the time slot 2 this switch will be closed and this will be opened, such that for each time slot only one signal, one user signal will be passed and the second user signal will be passed in the second time slot. We have DC signal in this board and 2 kHz sine wave and DC signal 2 and the 4 kHz sine wave. So I will demonstrate by this experiment how in different time slots signal will be passed through a single channel. And the digital oscilloscope, this is digital oscilloscope. Main power switch of this digital oscilloscope is this one, and we have two channel, this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs and these are the horizontal position adjusting knobs and this is the time scale adjusting knob, and the probes for the digital oscilloscope and the connecting wires. Let us start the connections for the current experiment. Take the connecting wire, connect to the DC signal, and DC signal is connected to the channel 1 input, and take the connecting wire, other connecting wire, and connect it to the 2 kilohertz sine wave and next to the channel 2 input. Now let's connect the probes. Take the channel 1 and channel 2 probes of the CRO. Channel 1 is connected to the 2 kilohertz sine wave positive, and negative of the probe is connected to the ground. The same way channel 2 probe is connected to the sample and hold output, and negative is connected to the ground. This completes the connections. Now let us switch on the Cytec board as well as the digital oscilloscope. Click on the auto set button and wait for a moment, and then press the stop button such that we can observe this input sine wave for the channel 2 and DC wave for DC value approximately equal to 0 volts to the channel 1, such that we can see here for particular time slot it is sampling the amplitude of this sine wave. For the adjacent time slot it is maintaining the 0 volts, such that for the channel 1 we are only transmitting 0 volt, and for the channel 2 we are transmitting the sample magnitude of the sine wave, such that we are sharing the time slot 1 and the time slot 2 for the channel 1 and the channel 2. We can increase or decrease this magnitude of the channel DC magnitude by turning this knob. So now you can observe the changes in the magnitude at the time slot 1. The time slot 1 magnitude is changing by changing the DC magnitude. This demonstrates the time division multiplexing operation of this experiment.
At MSR, you mark your imagination.